Solomon 39 again, and today we'll be talking about pulsars.
The night sky is full of wonders, but for thousands of years, nobody knew that within a smudge in the constellation Taurus, the corpse of the star flashes on and off every 1/30th of a second, their highly magnetic pole sweeping across Earth like a lighthouse, a beacon of light from our intergalactic brethren, as if they were little green men trying to catch our attention. This is a pulsar, not little green men, but still as curious and as exotic as them. In this episode, we will be talking about pulsars and the ingenious woman who discovered it. What are pulsars? Pulsars, as suggested by its name, beat rhythmically and regularly like a heartbeat. They are neutron stars, which are the crushed core of a massive star that seem to rapidly pulsate when their magnetic poles sweep across the Earth. The first pulsar was discovered by Dame Jocelyn Bell Burnell and her supervisor, Anthony Hewish, in 1967. Pulsars emit all the wavelengths from the electromagnetic spectrum, everything from radio to gamma waves. They can rotate from once every 23.5 seconds, the time taken by the pulsar PSR J0250 plus 5854, to nearly 720 times a second by PSR J1748. The acronym PSR in here means pulsar. They are extremely dense, being formed of an extremely strong crust, made from the crystals of a neutron-rich materials, and underneath is a superfluid, a frictionless liquid that exhibits many strange qualities, such as being able to climb out of cups as exhibited by superfluid helium. Because pulsars are so dense, they have extremely strong gravity, on average 2 billion times the Earth's. And as a side effect, an object dropped from even 1 meter away would accelerate to speeds of over 7 million kilometers per hour. If you made a bullet out of the matter contained inside a neutron star, like what explained in the book What If, it would weigh as much as an Empire State Building and the surrounding blocks of Midtown Manhattan, or to put it more bluntly, 10 billion kilograms. To walk towards it might feel like being on a slope that gets steeper every time you walk towards it, as your brain is not used to non-uniform gravities. Here comes the question, where do pulsars come from? To answer that, we need to explain the birth and lifetimes of a star. All stars form from clumps of gas and dust in nebulae, which are gigantic clouds of gas and dust formed from the death of the previous star. These clumps of gas have more gravity than the surroundings, attracting more and more dust and gas in the process. Then the clump of gas starts to contract and heat up in the process. This becomes the core of a new star. When the core gets hot and dense enough, nuclear fusion starts and a star is born. The smaller stars are relatively cooler and can shine for a longer time, estimated to be in the hundreds of billions of years, whereas massive stars can only live for a couple million years. It is the massive stars we are interested in today. For most of its life, the massive star will be white to blue in color, doing regular hydrogen fusion. When this star has fused all the hydrogen in its core, it starts using helium as its energy source. The star's helium resources are not infinite, however, and the star starts using other efficient products to provide energy all the way until it is being forced to fuse iron. Simultaneously, the star becomes a red supergiant. When this red supergiant starts to fuse iron, it cannot produce enough outward pressure to hold the star together. And this is the time when the star's life ends with a spectacular supernova, an enormous explosion which leaves behind only the compressed iron core of the once massive star, our neutron star. If we are lucky, its magnetic poles are shining towards the Earth, and our pulsars are formed. Not all neutron stars are pulsars. Pulsars are only pulsars when the light they emit from their poles appear to sweep across the Earth. If I took an orange and put LEDs on either side to portray poles, if I rotate it perpendicular or at right angles to the poles, you will not see the poles and it will not seem to pulse. If I rotate it with the pulse facing you, however, then you will see the pulse in the frame more than you would see it out. This is the difference between a neutron star and a pulsar. Now the problem is to detect the pulsar. You could always rely on the naked eye, but the chances are almost 1 in a million that you could see it. Not many pulsars are in the visible spectrum. This is where radio/X-ray/gamma astronomy helps us. By pointing the telescopes to the sky and following Earth's rotation and looking for spikes that are regular, you might find a pulsar. Pulsars were a significant discovery, shedding more light into both science and the social customs at the time. They helped prove the existence of the then theoretical neutron star, and the discovery led a Cornell University scientist to publish a paper in Nature linking the pulsars with the neutron stars. Because it is so in time with its speed, the accuracy of the timing of a pulsar is used for important tests on the theory of general relativity on time dilation effect, when time is being delayed by the force of gravity. It was also a spotlight that illuminated the real role of women in science, unlike being objects that were used and thrown away, but as capable people who have intellect and can contribute more to society than just being housewives. Even though Anthony Hewish won the 1974 Nobel Prize in Physics for the discovery of the pulsar, his legacy remains in the shadow of one of his PhD students, Jocelyn Bell Burnell, who was a legendary female scientist. When Dame Jocelyn Bell Burnell was first born in Lurgan in Northern Ireland, she did not know what she would achieve later in her life. Born to M. Allison and G. Philip Bell, her father was an architect who had designed the Armagh Planetarium, and during her visits there when she was a little girl, she was encouraged by the staff to pursue astronomy professionally. Young Jocelyn also discovered her father's books on astronomy. At the age of 5, she entered the preparatory department of Lurgan College, where her parents and other schoolmates' parents protested against the girls not being taught science, the curriculum favoring traditionally feminine crafts, being taught cross-stitching and cooking. Jocelyn failed the 11-plus exam that was given to many 11 to 12-year-olds in England and Northern Ireland, hoping to get into grammar school and other schools that use academic selection to choose their students. Not to be deterred, her parents sent her to the Mount School, a Quaker boarding school in York. As a PhD student at Cambridge studying under Anthony Hewish, she was one of the 5 people in the group that built a homemade radio telescope. The telescope wasn't built with fancy electronics, as what people would do now, but with aerospace cable that couldn't be coiled up. As an added downside, the miles and miles of aerospace cable couldn't touch the wet grass to stop an electrical short circuit, so she had to support the cable with wooden beams that held it up. In total, over 1,000 were used. After the project was finished, all of the other members of the team disappeared and were attracted to other projects. Jocelyn was the only one left and was the only one using it for finding quasars, extremely bright black holes. To find quasars, Jocelyn utilized a phenomenon called scintillation. By definition, quasars when seen by radio telescopes are very bright and very small. Because the solar wind that the light has to pass through is uneven and has clouds of plasma in one moment and a completely clear sky the next, by detecting the small fuzziness on the chart, you could see if the object you were pointing your telescope at was a quasar or something else. Noticing that there were regular spikes in the chart every now and then, she locked it and didn't give a thought more about it, jokingly labeling it LGM for Little Green Men. Telling Hewish about the discovery, he quickly dismissed it as man-made interference.
Looking back, the
dismissal was within reason, as many things then made interference. Pirate radio stations, badly tuned cars, and many other things. When she found more and more of these pulsating stars, she started to wonder if the flashes were something else. The possibility that 2 or more aliens trying to contact each other was too remote and told Hewish about it. Jocelyn combed through miles and miles of the paper and went to Cambridge in the middle of the night to collect and organize it. The hours of work paid off, and they found much more evidence of these little green men. Writing a paper and sending it into the journal Nature, it was peer-reviewed by the journal's editor himself, John Maddox. The new discovery was well received by the general media, as people were greatly interested in the new discovery. However, as she revealed in a 2019 lecture at Sydney University, she related how the media was covering the discovery pulsars, with interviews taking a biased standards. Hewish would be asked on the astrophysics, and she would be the human interest part, asked about vital statistics, how many boyfriends she had, what anti blonde or brunette she would describe herself as, and was asked to undo some buttons with her photographs. The Daily Telegraph science reporter shortened pulsating radio source to pulsar. It was also a mistake to wear her engagement ring into the lab, as it meant that she would leave shortly after her marriage.
In Britain at the time, women were treated as inferior and only as objects, and were subject to discrimination. Jocelyn recalls that whenever she would enter her class, the Cambridge tradition of banging on desks and catcalling, which is making vulgar comments of a woman's body or a shrill whistle of disapproval, would commence and continue every time she went to class. The Nobel Prize controversy was no different, as the Nobel Prize Committee awarded it to her supervisor instead of herself. The sexism resonated throughout the astronomy community, and many objected to the decision of the Nobel Committee, including the astronomer Fred Hoyle, who accused Anthony Hewish of stealing her data, and later the Nobel Prize Committee was deliberately being unfair. Jocelyn responded gracefully, replying that she was a graduate student at the time, and only in exceptional cases should grad students deserve the prize, and this was not one of them. She also has jokingly mentioned that once a scientist wins the Nobel Prize, they do not win any more prizes.
Jocelyn Bell Burnell is truly the most influential scientist of the 20th century, from the gracefulness in the way she handled the Nobel Prize controversy to persisting through the taunts and catcalling in university. The loss of the Nobel Prize did not stop her, however, and she continued her scientific career even after her first son was born, working part-time in any science institution nearby her husband's work. She has won countless many more prizes, her most recent prize being the Special Breakthrough Prize in Fundamental Physics, all of the £2.3 million being donated to the Athena Swan Foundation, a charity that allows minority groups such as refugees and women pursue higher education in physics, a foundation where she was one of the key members to establish it. Jocelyn Bell has an outstanding legacy, and she proves to us that actions speak louder than words, and that to make something happen, you must do it yourself. I wish that in my generation, both the boys and the girls are allowed to have equal opportunities. I wish that in my generation, there is no more inequality in science. I, as with so many other people born in a first world country in this generation, am so much luckier than Jocelyn Bell that I am able to do what I love, science, but there is still more obstacles to overcome. The pay gap, for example, between men and women is huge, starting at 30% for Australia alone as of 2013, which is a 3% increase from 2012. I, being a girl for one, is happy at what we have achieved now, women being allowed in science more readily than the 1950s to 1990s, but the statistics and the bias pose incredible wastage of brilliant female minds. The Royal Society of Scotland estimated that doubling women's high-skilled contributions will benefit it by £170 million per year. A 1996 study of college freshmen in America shows that only 1/25 of women pursue a STEM subject in all the sciences, with the exception of life sciences including botany, zoology, and botany. Stereotypical beliefs may also contribute to the inequality, as well as some social customs, such as the women being viewed as less smart than men. The acceptance and recognition of women in science shows that we have gone a long way in raising the boundaries between girls and boys.
but it still reminds us of how far we need to go.
Hi, it's Ellen 39 again.
Thanks for watching this video. Please don't forget to like or subscribe to my channel for more awesome videos.